Let's talk about callback functions. Generally speaking, our JavaScript code is synchronous. That means that you have one line. So for example, we can display a console log, hello, and then we can have another console log, call Diddy. So we have that. Can you tell me eventually the execution order, breakpoints line number 2 and line number 3? So Eugene said 2 and then 3. That's correct. I mean, I hope no one is lost already, right? Otherwise, we have a structural problem in this bootcamp. Cool. 2 and 3, right? Let's run this. Line number 2, correct. Line number 3, and that's it, right? And then we got the messages. So that's good. It works. By default, JavaScript, it runs one instruction after the other. Easy. But sometimes that's not true. So, for example, if I have a function do something, and the function has a console.log hello, and then I have a set timeout of half a second, and then I have another console log outside. So can you please tell me the execution order now? So Tom said 3, 7, 5. Why, Tom?
So it does the first one and then goes to the timeout, and I'm guessing that's a promise. So it'll skip over that, waiting for the response, and then it goes to the seventh one, and then 500 milliseconds later we get the.
Yeah, that was mostly correct, except one thing we said. So first of all, the execution order is correct. So we'll go to line number 3. Eventually, we go to line number 3. Right, so in that case, Chrome is ignoring me, right, which is not ideal. That happens sometimes. No, sorry, it's not ignoring me, it's my fault. Why it doesn't work? What? It's correct, because I need a coffee, right? If I don't call the function, nothing will work, right? But if we call the function, so let's put it again. So Tom, so we got line number 3, then line number 7, and then line number 5. Number 3, then line number 7, and then after half a second, line number 5. That's correct. So the only thing that Tom didn't answer correctly is this is not a promise. We'll see promises now. This is a callback function. It's a function that runs after some time. Right? This is asynchronous. That's why even though from a visual perspective, code Diddy should happen before world, that's not true. Because JavaScript is creating a new execution thread here. So that will happen in the background, right? Asynchronously. That's the important thing. That in the long term, the more complex stuff you write with JavaScript, the more often you'll have to deal with asynchronous code. Some of you are already doing that. For example, if you're communicating the front end and the back end, when we have a REST call to the backend, /REST/shows, this is asynchronous. That request may take 2-3 seconds. We're not blocking the user experience, right? We can still interact with the application, but it may take a while to get the data returned. This is asynchronous. So one of the fundamental aspects to be able to write proper, powerful code is to be able to handle asynchronous code, which is not that simple, unfortunately. So let me show you the classic way to face asynchronous code. I'm going to create 3 functions which will return callbacks. So none. Yeah, that's correct. So function do something one will have a set timeout of for example, 1 second. So after 1 second, we'll display, we can display console log for now. Do something 1 done, and then we invoke the callback. So we'll do the same for function 2 and finally the same for function 3. Function 2, do something 2 done, and eventually we'll do the same for function do something 3. Do something 3, do something 3 done. I'm going to change the timing a bit. So the first function will take maybe 1 second to complete, the second function will take 2 seconds, and the third function will take 7/10 of a second. So now the way I'm going to invoke these functions is I'm going to call function 1, do something 1, and then because you see the callback function will be invoked when it's ready. This is a higher order function. This is included in the intermediate training already. So we can put that, right? So do something 1 is ready, then call do something 2, and once something 2 is ready, do something 3, and once do something 3 is ready, then something like that. So let's do something. Let's have some breakpoints. 23, 24, 25, 26, 4, oops. I can put a breakpoint there. Anyway. So 5, 12, 19. All right, lots of breakpoints today here, right? All right, can you tell me the execution order, please? I need to change the name of the second one. Thank you, Marta. That's correct. That's why it wasn't working. That's a good point. Thank you, Marta. Cool. Can you tell me the execution order, please, of the breakpoints? Osman? Four. And then what? 11, 26. That's it. Why not? Right? Why not? Okay. Right or wrong? Wrong. Wrong. Next one. Victor.
Invoke the function first.
Invoke the function first. Okay. Okay. That's on
23.
23. Yeah.
Then 4.
Okay. And then what?
Then 24.
Yeah. I mean, yeah. Okay. That's fine. And then what else?
I'm guessing 11.
Yeah.
But will 11?
I don't know.
Because it's got. Yeah, because it'll wait for 4 to run and then run. I'm not sure, but I'm gonna say then 25.
Then 25.
18.
18.
And then 26.
What do you think?
Probably. I don't think it's right. I don't really understand how it works with the timing.
Will this work? Yes or no? Why?
Say no, because the functions are asynchronous.
So Grace said no. Okay, so what Grace says?
I'm going to go 4,
Yeah.
23, 24, 25.
So 4,
23.
23.
No. Start with 23.
Yeah, correct. 23,
24, 25.
24,
I'm not sure.
25,
And then I would go 18, 4, 11.
18, 4, 11,
26.
26.
Makes sense. But I don't know whether the bottom one's actually.
Sounds right. Oh.
Sorry?
I don't know.
Right. So
26.
first of all, that's interesting, right? It's a good thinking. It's not that simple. But there is some logic in here. So Victor is wrong. Gray is wrong. You both got close, to be honest. I think you got the idea. Well, but you defended, so so let me have a look. Yep. Gim. Yujin.
23, 24, 25, 18, 11, 4,
Wait a minute. 18,
11, 4, and then 26.
11, 4, 18, 11, 4, and then we say 18,
26.
18, 11.
26 can't happen until.
Wrong.
Oh well.
Marta.
Oh,
4 and don't know. Okay. Wrong.
I fucking tried. Is it 23?
Wait, Victor. You got your opportunity already. So Tom.
23, 24, 25.
Yeah.
Yeah, 26,
Mm-hmm.
18, 4, 11.
I like it.
Oh! I forgot that happened.
Wrong. And finally, Alex. Last chance. I mean, just change the combination, right? By you know.
Question mark, exclamation mark, question mark.
Right. Wrong. So I give you my what I think, right? And if I fail, everyone here will get a bonus in the board challenge. So what I think we will do is, I agree at the beginning, right? Most of you, I agree. First is line 23. So that's for sure. No doubt about it. 23, that's the first thing. Not 4, Osman. We cannot run line number 4 if we haven't even called the function, right? So 4 is not going to be the first one. Then it will go to this function, but because this is asynchronous, it will just continue to line 24. Most of you said that as well, right? That's fine. And then it will invoke do something too, but do something too is the same problem, right? This is asynchronous. So it will just continue to 25, 23, 25. So let me just keep just people who made it right, so then we can see what you did wrong. Assuming that I'm right, because if I'm wrong, then this is a pointless exercise, right? So, right, 23, actually, Victor, you said 4 first. So we got Gray, Eugene, and Tom. 23, 24, 25. And then, because we've run all these things, this block is sorted, right? And what we know that sorry, that's wrong. That's not even that. No, that's wrong. Wait a minute. Let me go back because that's wrong. You see? Right. So let me recap. So we start with 23. Sorry about that. So we start with 23. But then this is a callback function. So that will never be executed until this line is triggered. So that means that the next is 4. Right?
So Victor, let's go.
So Victor can get a huge score and even Marta, if any of them gave the right answer. We'll see. So do you understand why? So this function will never run until the callback is executed. The callback is here, is there, so the console log will happen first. Right? So it's 23 and then 4. 23 and then 4. Right. So Victor, you have the chance, right? So we'll see if Victor succeeds or not. So 23 and then 4, and then it will run the callback. So then it will run 24, right? 24. But then it won't run 25, because to run 25, it needs to call this callback first. So then it will run 11. And after running 11, it will run 25. And then, after running 25, it will run 18. And after running the callback on 18, it will run 26. So I think, Victor, you were actually right. Let's check it. Yeah. No, definitely. I mean, yes, of course. Let's check it. Cool. So, play. 23. Right. Then, will it go to 4? Yes. It takes a while. It takes 1 second, but it goes to line number 4. Right. And then, line number 5 will run the callback, so it should stop on line number 25. Sorry, 24, not 25. Yeah. So that's correct, 24. And then it should go to, after 2 very long seconds, it should stop on line number 11. 1, 2, here you go. Right? 11. And after 11, it will run the callback on line number 12, and it should stop on line number 25. Correct. And again, after 0.7 of a second, it will go to line number 18. Correct. And finally, it will go to line number 26. Correct. So, nice one, Victor. You'll get a bonus today.
Yes.
Right. Before jumping to promises, I would like to change the example a bit. Let me write it down somewhere. I'm going to change the example a bit. No, I'm going to keep the same code, but I'm going to add some breakpoints. Oh, sorry. I can put a breakpoint on line number 4 from. That's a bit exotic, right? Right, I cannot put a breakpoint on line number 4, so we'll skip it. But we got 2 new breakpoints, 11, and well, you see the new breakpoints, right? So now, let's start again. Osman.
What did you change? You just add
I added more breakpoints. I didn't change the code.
Just 11 and 18.
Correct. I just added 11 and 18. Correct. So Osman, no. Tom.
I me.
Yeah.
Okay, so
We're the only Tom here, right?
yeah. In a different order last time. So
Okay. Eugene.
24.
24. 6.
Yeah.
Okay.
25.
25.
11.
11.
Wait, where am I? 11. 12.
12.
18. No, wait.
Wait.
26.
26.
18.
18.
19.
19.
27.
27. Right or wrong? Right. I think Eugene is right and he'll get another bonus.
Really?
Well, we'll see.
We just copied Victor's answer.
No, because we did 2 more breakpoints.
You know,
So 24, 6, after 1 second, 25, 11, 12, 26, 18, 19, 27. Brilliant. So Eugene gets a bonus and Victor gets a super bonus. Right, so this is how callbacks work. If you don't understand something, please play with this type of example, right? I think they definitely help to understand the flow. That's okay, that's the way, historically speaking, we've been dealing with JavaScript stuff, right? But this approach has some limitations. So for example, first of all, this is not that readable. Do something one, and then inside of it, indentation, something two, something three. That's okay, we got just 3 functions, but we could have 10. Are we going to indent this structure to until here? You know, at some point this may not be that readable, right? The second issue is at the moment, so we run function 2 after we completed function 1. And we run function 3 after we completed function 2. So these are sequential, which in some cases will be perfectly fine, right? So for example, if we want to do several REST endpoints to the backend, first of all, get user details, one request, we get the details. Then once we have the details, again, give me the score, another request. Then once we have the score, show the results, and you know. So in some cases, it's good to do sequential order. But in some cases, we want to parallelize. What happens if we want to get the user score on the coding challenge and we want to get the user score on the board challenge? These aren't related, right? So we can trigger both in parallel for performance reasons, because then the UI will be ready quicker if we can parallelize requests. So how can we run these 3 requests in parallel? So eventually we have a message console log once everything is done. And let me rephrase that. How long this exercise takes to run end to end at the moment? 3.7 seconds. Let's try that. Let's see that. Actually, I've done a small change on my dev tools. You can do that if you want as well. So if you open settings, so you got an option called show timestamps. So if you want to evaluate performance, timing, and all these things, this is a good thing. For each console log on the left, you get the timing. So let's run the example. Look. So it starts, I mean, this is not exact, but this gives you a good feeling, right? And I think Tom is correct. So we start at 31 seconds. After 1 second, because it takes 1 second to complete the first function, right? After 2 additional seconds, more or less, it does the second function. And after 0.7 of a second, the third one. So in total, like he said, from 31 to 34.7, so 3.7 seconds. But imagine that these 3 requests are not related. What will be the cost of execution them in parallel? 1.7. Why 1.7? So I want to run them in parallel. So the cost of the algorithm will be the cost of the most expensive function, right? Because I want to wait until everything is ready. It will be 2 seconds. Because the bottleneck is the slowest one. But still, 2 seconds will be way more performant than 3.7 seconds. Do we agree on that? Makes sense, right? So, how can we run these 3 functions in parallel? We can do that. We can do that with callbacks. We can do that. We can do function do something 1, and then callback. So on the callback, oh, sorry, that's a function, right? So on the callback function, do something 1. Oh, so I want to invoke do something 1. Correct. I'm going to call a function check if ready. Something. I mean, this is very rudimentary, but this is just to prove the theory. So I'm going to have a variable here called let expected requests equals 3. So, and then let counter equals 0. So then I'll call a method check if ready. I'll do the same for function 2 and function 3. Function 2, and once we're done, check if ready. Function 3, and then check if ready. So can you tell me the code for the check if ready function? I want to if something. If what?
If counter equals expected request.
Will this work?
We haven't incremented the counter.
How can increment the counter?
Yeah, put it in do something functions, or you could put it in check and ready.
So we can rename that to progress and check if ready. Why? Because if we rename it just for readability purposes, can we do that? Will this work? Can we do that in this line without adding a new line? What do we have to change in that line to make it easier? Can we do that?
Go before counter.
What happens if we put it after counter?
We're only ever reached 2. Well, it will reach 3, but it won't include the check once it's reached 3. It will reach the check will-
Okay, let's do something. Marta, your turn. It's a bit complicated, and hard to read. So this takes 1 second, this takes 2 seconds, and this takes 7/10 of a second.
What will it return?
No, I want you to tell me I want Marta to tell me the breakpoint execution order. Oops. Right. So Marta doesn't know. And Eugene.
28.
So say it again.
28.
28.
41. No. Is it 41? Yeah, let's go for 41.
Yep.
No.
No.
Actually, let's go 28, 29, 41, 32, 41.
Wait. 41 and then what?
You said 32 before.
32 before what or after what?
After
Ah,
no, yeah, after 41, so we do a check.
Isn't the counter plus plus before?
Yeah.
And then we do 33,
33,
41,
41 again,
yeah, 36,
36,
37,
yeah,
41,
yeah,
42,
and 32, and 42.
I don't know.
Right. Right or wrong? Wrong. So now we got Alex.
Let's go.
I honestly a bit lost with this exercise.
Okay, next one. Gin. No. Victor. No, Victor, you got a super bonus today, so I think you got enough for today. No, that's it, right? That's it. So actually, Eugene already got a bonus, so you're not allowed to participate anymore. I mean, if no one gets the answer at the end, you have the chance to, but, right? So no, Victor, but we got Tom. 41.
So it's going to be 1.
So that's wrong already. Osman,
Oh, fuck. I can't see what I
say it again. 6. 20, 26. There is no breakpoint on 26. 28. 41, yeah. 32. Say it again. 41. No. 33. 41. 26. 36. 41. And? Say again? And 42. Right or wrong? Wrong. Great.
Can I have the same as Eugene but without the 42 again?
So you say the same as Eugene, but without the 42. Let me have a look. Right. So right, I mean right, not right, it's wrong. Right that I understood what you wanted to say. That's wrong. And again, if I'm wrong and any of you is right, you get double points, right? We play this gamble. So, and then Victor,
28,
28,
41.
28,
I mean, wait.
wait. Right, too late, sorry. Oh, you need to think about that before, right? You cannot start thinking at your turn. Right, I think you are all wrong. So I give you my theory. So my theory is, it will be 28. That's the first thing. I'm going to leave all the options just in case I'm wrong, right? So I think it will be 28, the first thing. And then, so for example, most of you, or 2 of you says next is 29. I don't really think 29 happens next. I clearly think next thing will be 32. Because this is asynchronous, right? So we will run this, and then, okay, it will wait for 1 second, but it will continue down, right? So it should do 32. And then it should do 36. But even ignoring that, you are still wrong. Because the majority of you, for example, said that 29 will happen before 37. Look, you, 29 and then 37. And Gray, 29 and then 37. Why? Why 29 happens before 37?
It's still saying 37, 29, 33.
Yeah, but look, this will take a second to run. That will take 7/10 of a second. So after 36, it should run 37.
You press enter and then not enter that.
No, wait.
Okay, it's not something else.
Yep. So it should run 37. And after 37, it should run 41. Because once we are here, what we know is after running this progress, it will run 41 immediately. And after 41, what's next? Should be 29 after 3/10 of a second. And after 49, immediately 41. And finally, we got 33, and we got 41, and we got 42. No, we don't have 42. So let's see if that's correct, and we'll see how to fix it. So let's try. 28, correct. So right. It's 4 of us. 32, so then it's just me, right? So It's either I'm right or no one is right. No pressure. 32, 36, correct. 37 after some time, correct. 41, correct. Oh, you ran 41 twice. Really? Oh, wait a minute. 30? No, wait, no, it moved the breakpoint. No, wait. Stop. Wrong, move the breakpoints, right? It wasn't there. Oh God, he ruined it. Now the breakpoints are. Oh God. No, that's correct. So okay, let me try again. I think the breakpoints are in the same place, right? Let's start again. It moved. I moved that one, right? That's the issue. It's sometimes. I want to put the breakpoint on 29. Let's see if it works. 28, 32, 36. After some time, 37, 41. Here you go. 29, 41 again. 33, correct. 41, and then the question, will 42 run? Well, we can see this is the last iteration. So what's the value of expected requests? Correct. What's the value of counter? Correct. Will run number 42 run at all? No. Right? This is a classic problem. We did a board challenge about that, right? About synchronicity, about how to coordinate these things. So how can we fix it?
The start of the counter.
Correct. You remember the difference between putting the plus at the beginning or at the end? Right. Let's put it here. I'm not going to put all the breakpoints again, but now that message should happen. So what will be the execution time of this algorithm from the first console log to the last one?
2 seconds.
So we start at 34 and we start at 36, so that's correct, 2 seconds, right? Which is more optimum than the other one. Cool, so this is the first part, callbacks. So you see that you can handle that. I mean, we've done that for years. Actually, in the node world, this is still pretty popular, right? However, many years ago, someone decided that that wasn't that great. And that person created something called the Q library. So the Q library was an idea that someone had to improve the readability of your asynchronous JavaScript code. Promises. So that guy that has that idea, and apparently the community liked it. So for example, Angular adopted it. So if you ever work with Angular, you got promises based on the idea of the guy. And because the community still liked the idea, eventually it became part of the standard. So 2 things here. First of all, the library is not necessary anymore, generally speaking. So it's bad for the guy because he had a very popular library. But the thing is, now what he thought is now part of the JavaScript standard, which is amazing, right? He can work anywhere. What do you know about JavaScript? I implemented the promise. You know, this is awesome, right? That's a really good thing. So let's see how to deal with these same examples, more or less, dealing with promises. So first of all, with promises, we don't want to return a callback function. So we can remove that. I'll leave the other one there for now. But we don't expect any argument in terms of execution order. So then how promises work is each function return new promise. So when you return a new promise, ironically, you have to pass a callback function. And the very first argument of the callback function is resolve. So resolve is like the callback. It's a way to tell that this function is over. So we can do that. The logic now is equivalent. So return new promise, and then I'll invoke this function once my logic is sorted. So we can repeat the same. I'm going to copy and paste it because it's literally the same thing. So 1, 2, and 3, obviously renaming the arguments and blah, 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 blah. 1, 2, and 3, correct. So then how do we invoke this function? So the first one will be the same. do something one. So we go here, do something one, and now this is the main difference. Instead of creating a callback function, you remember we did that? And blah, 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 boring. So now we do something different. We can do that. Dot then, do something 2. Dot then, do something 3. If we have 10 functions, this is way more readable. We are not inventing to the right. We keep everything organized, and it's more readable. Do something, then do something else, then do something else. Get the user, then get the score, and then get the whatever. Right? So let's see if that runs. Let's see if that runs. Right? So, right. As you can see, it worked. Do something 1, do something 2, do something 3. They run after each second because I copy and paste everything, right? But if we change the timing and run again, oops. So as you can see now, so it takes 1 second more or less to display the first result. It takes 2 seconds more or less to display the second result, and it takes 7/10 of a second more or less to display the last result. So this is equivalent. That's the way we chain requests. This code becomes way more readable, way more readable. Because even though the functions we need to return that, then it's way easier to chain them, right? In that way. So they will be executed sequentially, and they can communicate. They can talk to each other. So for example, if we want to send the result of do something 1 to do something 2, because it's a chain, right? When you're building a car, the output of one step is the input of the next step. So we have to communicate them somehow. So we can do that. Look, on the resolve of the first function, we can pass an argument. That means that on the input of the second function, we can receive the argument. And likewise, here we can pass another argument, and then it will be received by the next function. So, can you tell me what the console logs will print now?
So first you get do something 1 done.
Yep.
Then you get do something 2 done with hello afterwards.
Yep.
And then you get do something 3 done with Kadiri.
Okay. Let's have a look. Correct? Correct. That's correct. That's correct. Yeah. So that's the way you can pass values, because usually the output of a function will be the input of the next one. That's why we are chaining them. Right? Then let's talk about parallel execution. Do you remember what we did before about how to run functions in parallel? Right. So with promises, there is a very sexy way to run functions, to run asynchronous functions in parallel. Look what we can do. We can do promise.all, and then with promise.all, we can pass an array of functions. So if we do that, we can do dot then. Let's move it to a new line. So in that particular case, it doesn't make sense to send. Well, it does. Well, let me rephrase that. So the functions are not connected because they will be triggered at the same time, right? So they are independent. However, we can still send data. Look, the first one resolves hello, the second one resolves Codiri, the third one resolves world. So that argument here doesn't make any sense because we are not passing arguments from one to the other. However, we'll see what everything returns at the end. So you see, I'm calling the three functions. do something 1, do something 2, and then do something 3. Can you tell me what the value of result will be? So Gin, result is Marta. Tom.
World. Hello.
What? Like all together? Separate by what? By at? By the pound symbol? By question mark? Separated by what?
So they'll each be an individual string.
Individual string. But then result is a variable, right? So how do we do that?
See the rest of it.
Array.
So Victor, how you do the array?
I don't know. I'm just guessing an array of strings and the three strings separate. So what would I have to do? I have no idea what's going on.
Okay, Victor I think is right. That's correct, and it makes some sense, right? Because look, we're invoking an array of three functions. Our result will be an array of three values. That makes sense, right? Let's see if it works. So I expect, as Victor said, to receive. Well, you said wall first, by the way. Why wall?
Shortest line.
That's a good question. That's a really good question. Really, really good question. In reality, that's not correct. Because what Victor thought is that the results will depend on chronological resolution. Because wall happened first.
Oh, I see what you're saying. So it will do run all of them, and then when the last one comes through, it will just
Correct.
as they were put in.
Correct. So even though the approach is correct, it will return an array of strings. The order is not correct. Why? Because if that was true, it will be impossible. If we had to deal with the result, how do we know if the index 0 is the first, the second, or the third? In that case, it's deterministic. But if you go to the backend, its request may take its time different timing, right? So that's not correct. That's not correct. So the array here always refers, the first element is the first request, the second element is the second request, and the third element is the third request, regardless of which one finished first, second, and third. So then, what's how it looks like?
Hello, Query World.
Correct. Correct. Which makes sense, right? Because now it's deterministic. If you want to access hello, you know that it will be always the first element of the array. So let's prove that. Did it run it? In a second. That's not running. Wait a minute, it was on top. Sorry. It was on top. Okay, let's try again. Look. Eventually, hello Codiri wall. You see? It is an array. So if we want to do something with do something one, so we can do the first result is result 0, right? It's an array. Makes sense, right? Do you know, this is the classic, well, not the classic, but this is perfectly valid. Do you know how to destructure this variable? We'll do a workshop about that. But there is a sexy way to organize that, right? Because we can do that. We can do, so, look, we can do the result of do something one is result, let's call it results because it's an array, right? Result 0. Then we can do the same thing with do something 2, results 1. Do something 3, results 2. But we can do that. Look how nice this is. That's it, result one. So we'll do a workshop about that. We'll do a workshop to see how to destructure arrays. So what we're doing now is, I know that this will receive an array. So instead of creating a variable that will host the array, I will destructure it. And I will say, please create 3 variables. So the first element of the array will be assigned to the first variable, the second element of the array will be assigned to the second variable, and the third element of the array will be assigned to the third variable. So then I don't have to do index 0, index 1, index 3, which is a bit dodgy, right? I have each value on each variable. So if we try that, it should run hello. That's it. Right? The structuring. Any question? So the very last thing I would like to do today is to explain something different. We've been always talking about very optimistic scenarios where we have the front end, we call the back end, everything is fine, we return data, the user interacts with the data, he pays for using our platform, we make a lot of money, blah, blah, blah. But in reality, things sometimes fail, right? So I would like now to talk about how to handle erroneous scenarios. So let me go back to the previous example where we have a chain of functions. I think it was pretty good, hopefully. Yeah, so let me see if it works, first of all. So let's run it again. Something 1 done, something 2 done, hello, something 5 did. Okay, so that works fine. So now, look at what I'm going to do on the function number 2. I think I can get rid of the console logs for now. So let's simplify everything a bit. So no console logs. But here, you remember resolve is the first argument of the promise. But then we can have another argument called reject. So reject will be invoked. If you invoke reject instead of resolve, the chain will be cancelled. So let's do something. If value equals hello, then resolve. Else, reject. You see, we can decide how to deal with the execution. And what do we look? What do we do now if the promise gets rejected? We can add a new line at the bottom, set catch. Right? So for example, if we are invoking the backend and because of whatever reason the node backend is not available, we can display an error to the user. Oops, something went wrong. Or we can redirect him to another page, right? So we can capture the execution. So now, the question that I'm sure you are now expecting. I'm going to add some breakpoints, and you'll tell me eventually the order. There's a lot of code here, right? Right, so can you see anything? Not really, right? Okay, let me just remove some lines just for readability purposes. Right, so let's try that. So breakpoint, breakpoint, breakpoint. Yeah. Right. Anyway, yeah, I think that's better than nothing. So here you go. That's it. That's it. So execution order, guys. Who wants to start? Everyone apart from Victor, and Eugene. For example, Osman. No clue. Marta. 29. 5. 7. 13. 22. 24 and 33. Right or wrong? Wrong. Great.
29,
29,
5,
5, 7,
7, 13,
13,
and then 33.
33. Right or wrong?
What's that 7 on? It's 7 on the resolve.
Yep.
On set timeout.
On the resolve.
Oh, resolve.
Yeah. So is Gray right or wrong? Right. I think he's right. I think he's right.
Surprised himself.
So the main issue, the main problem with Marta's approach is she assumed that something free will be executed, right? 22 and 24. But in reality, because something 2 will reject, right? Because the value is not hello, it's hello world, it will cancel, it will stop the flow, right? So it will run this, fine, this will be resolved, okay, next step, function 2, wrong, so function 2 will abort the execution, so that means that in reality, function 3 will never be executed, so the error will be captured here, right? That's the main issue. So let's see if Gray is right or not. Wait a minute. It moves the no. That's Chrome thingy, right? Sorry. Let's abort that. It moves the breakpoints. Oh, that's horrible, right? Right. Let's move the breakpoints again. So 5, 7, 13, 33, 29, or something like that, right? Okay. Let's try again. Number 1. Oh, that's wrong again. Well, Chrome is moving the breakpoints all the time. Don't ask me why. Anyway, that's horrible, Google Chrome. Don't move my breakpoints. Don't do that. It's horrible, right? Why can't the breakpoint? So this is completely broken, right? But I can clearly tell you that Gray is right. Why? Let's review that. Because it will clearly do line number 29 first. That's the first thing, right? So we want to invoke the function. Without that, nothing will happen. And after that, it will go to do something 1. And then it will return a promise. Fair enough. So eventually, after 1 second, it will resolve the promise with hello world. Once the promise is resolved, it will then run do something 2. So what will be the input value of do something 2? Hello world, correct. Hello world. No problem. Let's evaluate hello world. Is hello world equal hello? No. Will this promise be resolved or rejected? Rejected, correct. If it's rejected, do something 3 will never ever run because the execution will be immediately aborted. That means that the result will be captured by this catch block. Let's see if we can run it without the breakpoints. So without the breakpoints, we should clearly see a console log, and that console log will display not good. Correct. That console log takes, how long is it? About 3 seconds to run, more or less. It's 1 second because of the first function, plus 2 seconds because of the second function, more or less, right? Actually, if you don't put, you know what will happen if you don't put the catch block? What will be the output? Error. So sorry, wait a minute. Gin said error. Marta said not good. It's a string. So Gin is right. If we're handling promises and one of the promises is rejected and we are not capturing the error, JavaScript will complain. We'll throw an error. Let's have a look. See? In reality, Marta is partially right as well, because this is the message of the error, right? So they are both right in reality. So you got an error and the error says not good. So you go both get a bonus. So this is the way promises work. As far as possible, if you want to make proper, scalable, and readable code, use promises. Right? Now there is a very intense discussion in the JavaScript community because there is an American guy who I had the opportunity to meet some years ago, who Ben Lesh, I think it's called. He created an evolution of promises called observables. Maybe you heard about them. So this guy wants to bring observables to the JavaScript standard. So what are his points of view? So what he says is that promises are really good, but they have two main issues. Issue number one is promises can't be cancelled. So once the process starts, it will continue until the end, right? So if at some point you want to cancel a promise, you can't. I mean, they will be automatically cancelled if you reject, right? So they will be cancelled if something goes wrong. But on the happy path, they can't be cancelled. They will always continue until the end. And his second complaint is that promises can't be repeated. So you cannot run this thing multiple times. Well, you can have a loop, right? But there is no obvious way to say run this algorithm 3 times as part of the promise standard. So this is what the guy is trying to do. And yeah, if you check on the TC39 group in GitHub, where all the new standards of JavaScript get discussed, so there is a very hard discussion. People in favor of introducing it, people against that. Yeah. We'll see how it goes. Cool. So that was pretty much it, guys. Any question? No? Will you start using promises from now on? No? Why not, Victor?
I need to mess about with it to understand it a bit more.
Yep.
Yeah.
Yeah. Please make sure that on your first job interview they will ask you about promises. So they will probably show you a board challenge with a promise. And they will tell you, can you explain what's going on? Something like that. So please do literally what I did today. Go to DevTools, play around with some examples, add some breakpoints, try to figure out the execution order, right? Do it. It looks very weird today in 2018, at least on the front end. On the back end, yeah, still weird, but not that much. But on the front end, I mean, if I receive a pull request with some callbacks, go back to the 90s. Don't do that anymore. Right? Use promises. Anything else? No? Okay, that was it. Thank you, guys.